In the last video, we looked at different ways to graph single categorical data. Remember bar charts, pie charts. But what if we wanted to compare two categorical data sets? This video will focus on comparing categorical data. We're going to look at two-way tables, or they're also called contingency tables. And this right here is a two-way table or a contingency table. This data represents a national survey of American adults in 2009, and they were asked to give their age and to classify their interest in politics. Very much, somewhat interested in politics, or not much interested. Age was grouped into these three categories. If we look at the two-way table, we can see ages are represented in the columns and their political interest in the rows. How about if I were to ask you how many people were between 18 and 35? You could look right down here and see that there were 385. Or how many people were not much interested in politics? Not much interested would follow straight across here to 381. And finally, how about if I asked how many people were in this survey? Well, down here in the far right corner, you can see that there was a total of 1,265. So let's start to look at some questions. Question A says, what proportion of the survey respondents were between the ages of 18 and 35? Well, between 18 and 35, we already said, was 385. And if we want to do it as a proportion, we would write that over the total number, which is 1265. So here is the proportion of respondents that were between 18 and 35. And we can continue this for the next two questions. The proportion between 36 and 55, right here, 531 out of 1265, and then those over 56 or 56 and older, right there, 349 out of 1265. Well, what you have calculated is called the marginal distribution, and more specifically in this example, the marginal distribution of the age variable. Marginal, notice, all of our answers are in the margins. Marginal distributions only deal with one of the variables, either what percent were a certain age or what percent are not much interested in politics. Now we want to start to look inside the table. Restrict your attention to just the respondents that are 35 and older. 35 and under, sorry. What percent of these young respondents classify themselves as having not much interest in politics? What you want to ask yourself is, what group represents the total of what I want? That will end up that will be your denominator. So out of the group that's 35 and under, well, when we look here at 35 and under, I now only want to focus on this column. So out of this group, which how many people are in this group? There's 385. So out of 385, how many are not much interested? You guessed it, 146 out of 385, which is equal to about 37.9%. So try answering E and F right now. Go ahead and pause the video and try answering questions E and F. Did you get 49.9% of 18 to 35-year-olds were somewhat interested, and 12.2% of 18 to 35-year-olds were very much interested in politics? You have just calculated the conditional distribution of one variable, political interest, on another variable, age. And all three of the percentages, 37.9, 49.9, and 12.2, add up to 100% of those that were 18 to 35. And we could continue to fill in the rest of the chart as well. Notice if we look at the column for age 36 to 55, all of these answers should have the denominator 531 because we are only focused on the 531 people that were 36 to 55. Now you could also focus on the condition of age on each of our 3 political interest groups. Here we will no longer be looking at columns, but looking at rows. So if I want to look at the age groupings, 18 to 35, 36 to 55, and 56 to 94, on not much interested in politics, how many people were not much interested in politics? Hopefully you said 381, and each one of these has a denominator of 381. And again, adding all 3 of these probabilities up will add to our 100%. So be careful of the wording of the questions. If you're looking for the conditional distribution of political interest on age, you're looking here. And in fact, I should be circling or going up and down because we're looking at ages. If you're looking for the conditional distribution of age on political interest, you're now looking at the rows. And finally, read questions carefully. It's important to think about what is my denominator. In dealing with conditional distributions or proportion, it's important to keep straight which category is the one being conditioned on. For example, the proportion of American males who are senators is very small. Not very many people are senators. But the proportion of senators, think about how many senators there are, that are American males, that's going to be a large proportion. So pause the video and try to answer these 3 questions right here. Here's our original data. What proportion of respondents aged 36 to 55 classified themselves as not much interested in politics? Well, our denominator is right there, or right here. So out of 531, there's 146 that were not much interested in politics. For question H, down here, what proportion of those not much interested in politics, there's my denominator, 381, are 36 to 55. Notice that's still the same numerator. And the last one, what proportion of the people in the survey? How many people were in the survey? 1,265. That will be our denominator. So out of that group, how many are 36 to 55? And that's still our 146. So 3 very different answers. So good luck identifying your denominators. Remember, they're in the margins, and I'll see you soon in class.